Alright, so today is 3-8, and we're going to talk about parabolas today. I am on page 9. Make sure you go ahead and get this set up in your notebook. Make sure you put the date. We're talking about this is parabolas. Parabolas. Okay, feel free to pause the video if you need time to copy it down. Alright, I'm going to go on to my page. So we are talking about, like I said, parabolas. Okay, so what a parabola is, it's basically a quadratic graph. Okay, so it goes like this, or it can go like that, right? And today's date is 3-8. So let's start off with our objective. Our objective today is I can apply factoring and zero product property to parabolas and graph them. So objective, we have a couple of objectives. So I can apply factoring and zero product property to graph a parabola. So that's our first one. Our second one is I can identify the parts of a parabola. So, I want you to know that you can identify the parts of a parabola. We're going to start off with that one. You can do it when you have a graph or when you have an equation. You can go both ways, all right? So, I'm going to list the parts over here. We're going to do the equation side first. So, from the equation. And then over here, we're going to graph it, okay? So, graph. Alright, so the parts, we're going to start off with our y-intercept. That's something that we are familiar with. So the y-intercept. Okay, so that is, on our graph, that's where it crosses the y-axis. In the equation, we're going to have this equation, so we're going to do it in, that's supposed to be an x. F of x equals 2x squared plus 12x plus 16. So in an equation, the y-intercept is just like when we do the y-intercept on a linear, it's the constant at the end. Okay? And the reason that works is because it is when this f of x, okay, that is going to be what we solve for, but it's when x is actually 0. So it's f of 0. So 2 times 0 squared plus 12 times 0 squared plus 16. These go away. We get 16, right? So our y-intercept is going to be a 0 for an x, and then it's going to be a value for the y. Okay? Now, let's talk about our x-intercepts. Okay? The x-intercepts, we might have more than one, okay? So we have the option of having up to 2, okay? So if we look at our parabola, let's say this is our graph, yeah? This one crosses the x-axis twice, whereas maybe our graph is actually up here, and this one only crosses once, okay? So we can have anywhere between 0, 1, or 2, okay? So I'm going to give you an example of 0 x-intercepts. So 0, okay, meaning it doesn't cross the x-axis at all. So if we have f of x equals 2x squared plus 8x plus 12. And the reason it won't cross the graph at all is because we cannot factor this, okay? It's not factorable. This one, if we only have one, all right, this is kind of like what we were doing yesterday where it's a perfect square. So f of x could be x squared minus 4x plus 4. And the reason that works is because if I factor this, I end up with x minus 2 and x minus 2. So when the number inside is the same, if we solved for it and we set it equal to 0, we would end up with x minus 2 equals 0. So then x would be 2, right? So our x-intercept here is actually a point, so that when y is 0, our x is 2. Okay, so we'll have an x here and y will be 0. We set our y equal to 0. And it is always a point, so we want to write this as 2, 0. An example where you might have 2 is our typical example where we can factor it all the way. Okay, so let's say we have f of x equals x squared plus 6x plus 4. I'm sorry, plus 8. Okay, so if we factor this and we set it equal to 0, we end up with x plus 2 and x plus 4. When we solve using our zero product property, okay, we end up with x equals negative 2 and x equals negative 4. So as a point, our y value is 0. These are our x-intercepts. And we're actually going to graph this one over onto the right. Negative 4, 0. Okay. So our x-intercepts, we can have 0, 1, or 2 of them. Okay. The 0 one, we'll look at the graph in just a minute, means it doesn't cross the x-intercept, the x-axis at all. This one means that the vertex is on the x-axis, and this one means that it's crossing through twice. Okay. Now we're going to talk about the vertex. Okay, so the vertex of a function is going to be, it's also called the max or minimum. Okay, when we are looking at this, we actually have to plug in and we have to solve for a certain value. So the vertex is a point, and we say negative b over 2a is the x value, and then we have to plug it in, and that's going to be f of negative b over 2a for the y value. So let's do an example. So if we look at this one right here, let's find out what the vertex of that one is. So f of x equals x squared plus 6x plus 8. All right, if we remember, the coefficient of the x squared is our a, this is our b, and this is our c. Okay, so I'm just going to rewrite that ax squared plus bx plus c. Okay, so negative b over 2a, our negative b is going to be a negative 6. It's positive, so I just write a negative times a positive is negative. 2 times a is 1. Well, negative 6 divided by this becomes 2 is negative 3. So that's going to be the x-coordinate of my max or my min. Now I have to take f of whatever this is and solve for it. So I'm going to plug in negative 3. And evaluate what that would be. So negative 3 squared is 9. 6 times negative 3 is negative 18 plus 8. 9 minus 18 is negative 9 plus 8 gives me negative 1. So that is what f of negative 3 is. So if we write this as a point, my x goes first, so negative 3, and then my value for f of negative 3 goes second. So that would be my vertex for this particular graph. Okay. So one clue, a maximum will happen when this is a negative up front, and a minimum will happen when this is a positive up front. Okay. Last but not least is our axis of symmetry. So we have this thing called an axis of symmetry. So an axis of symmetry is something that is kind of right in the middle of the parabola. Okay. It is actually just x equals negative b over 2a. It goes right through the vertex. So for this particular example, if f of x is still x squared plus 6x plus 8, then my axis of symmetry would just be negative b over 2a, which we said is negative 6 over 2 times 1. So we get negative 3. So my axis of symmetry is a line that goes through x equals negative 3. All right, so now we've got to put all this together in a graph. So I want you to come on over here. Feel free to pause the video and go back to this if you need. So pause it now if you want. Now we're going to come up here and we're going to graph all of this, okay? And I'm going to use a different color pen so you can see it. And instead of using one mark for each line, because I have my x's are pretty small, I'm going to use, let's see, 1, 2, 3, 4. Just kidding. I'm going to get my white out real quick. I'm going to move my y-axis over here. And the reason I'm doing that is because my x-intercepts are negative, and my vertex is negative as well. Okay, so from a graph, we can go and we can plot these points, and then we can label them. So our equation, we're gonna graph the function f of x equals x squared plus 6x plus 8. That's the function we're gonna graph. So we already found that the y-intercept is just the value here. So we need to go up to 8. So that's actually pretty high. So 1, 2, 3, 4, 5, 6, 7, 8. We're gonna put a dot, and this is going to be x is 0, y is 8. Alright, that is our y-intercept. So y-intercept 0, 8. Now we're going to do our x-intercepts. So our x-intercepts, when we found it here, let's see, we've got x is negative 2, so x-intercepts negative 2, 0, and negative 4, 0. So I'm going to go negative 2, 0, and negative 1, 2, negative 4, 0. Oh, negative 2, 0, negative 4, 0. Okay, so those are our x-intercepts. That's where they're crossing the x-axis. Our vertex, we said when we plugged it in over here that our vertex is at negative 3, negative 1. So if we go to negative 3, we go down to negative 1. Okay? So negative 3, negative 1. Last but not least is our axis of symmetry. And what this is it's a line that goes straight through our vertex, and it makes it symmetrical. So what we can do is, you see this, our y-intercept right here? From the line, it is 1, 2, 3 away. So if I go 1, 2, 3 away here, I can put another point because it is symmetrical. All right? So our axis of symmetry is a line going through x equals negative 3. All right? So now we can connect the dots. Okay, and we want it to look like a parabola, so it's going to be a little curved. So it's not going to be perfect, but I'm going to come down, touch the vertex, and then go right back up. I might need to lift my pencil or marker up. Okay, that's what a parabola would look like. So that one has 2 x-intercepts. Let me quickly show you what would happen if they didn't have any. So 2 x-intercepts is above. 1 x-intercept would have the vertex, like we said, on the line, like this. Okay? It only crosses the x-axis once. If it had 0 x-intercepts, then instead of ever crossing the x-axis, it would either be above or below and going in the opposite direction. So these are 2 positive examples. Okay? We can also have negative ones. Alright? So they can be going down and still only crossing once. And it could be going down and only crossing. Okay? Alright guys, so that was a lot of information. I want you guys to go back over and find a couple things that you didn't understand, rewatch the video. Feel free to skip ahead the second time and find the parts that you didn't understand. In class, we are going to be working on identifying these parts. So we want to be able to identify these 4 things. The y-intercept, the x-intercept, the vertex, which we also know is the max or the min, and the axis of symmetry. Okay? These are super important. You're going to need to use them in class. And then also what we're going to learn going forward is how to identify those things if you're just looking at the graph. So just looking at the graph, the x-intercepts, where they cross the x-axis. The y-intercept is where it crosses the y-axis. My vertex is that turning point. Remember, the tipping point? And then the axis of symmetry is the line that goes through the vertex.